Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Herwan Sulaiman. Okay, today I will present my paper. Okay, the title of my paper is Economic and Emission Dispatch Solution Using Evolutionary Mating Algorithms. So basically, this is student's paper. Okay, Ahmad Shahir bin Abdul Aziz is the author, and I am the co-author as well with Dr. Zuriani Mustafa. So this is the table of content of my presentation. Consists of introduction followed by evolutionary mating algorithm, and then evolutionary mating algorithm for solving the economic emission load dispatch. We proceed with the result discussion, and finally the conclusion. So as introduction, basically materialistic approach contributes a significant role to machine learning as well as optimization problem to obtain good results. By opting the materialistic approach, the parameter of interest can be efficiently optimized that we can get a good generalization. So basically, meta-heuristic can be categorized into four groups, major groups. The first one is the evolutionary algorithm. Basically, the EA consists of the algorithm that inspired from the evolutionary process that generate a new offspring which inherited from their parents. So for example, a genetic algorithm, differential evolution, and evolutionary programming. And we move to the second category, is the swarm intelligence. This is a model that swarming behavior of animals, birds, and living things in nature. For example, the particle swarm optimization and colony optimization, artificial bee colony, grey wolf, moth flames, and barnacles mating optimizer. The third one is the physics based. It's motivated by based on the various physics law and phenomena. For example, the gravitational search algorithm, Big Bang crunch theorem, and many more. And then finally, the human base that inspired by the various human activities and interactions that we have, for example, for the harmony search algorithm as well as teaching learning based optimization. So this is basically the overall categorical of the meta heuristic. So EMA, evolutionary mating algorithm, is the most recent algorithm that we have developed in this year. Basically, we use this algorithm to optimize the power output of generation to obtain the minimum cost and emission. The performance of EMA algorithm is evaluated by, we use the 10 and 40 generator units, but in this presentation I will present only for the 10 generator units. For the 40 generator unit, you can refer to the paper. And then the comparative analysis are conducted with other algorithms such as a cocoa search algorithm, flower pollination algorithm, and barnacles mating optimizer. Okay, we move to the evolutionary mating algorithm. Basically, it consists of it based on the mating algorithms, and then we use the Hardy-Weinberg principle that consists of this. We call it the hemotype or the genotype that we can contribute to the new offspring. So that and D represent of dad, M represent for mom, that can give the significant behavior of the offsprings. So we use the EMA for solving the EELD. So the goal of the study to get the optimized of power generation. So that's why the detailed equations we can refer to the book or as well as our paper. Normally we use the quadratic score function and quadratic emission functions that we, from the bi-objective, we transform into the single objective by using the penalty factor. And then EMA is employed as serve as an optimization tool. And then the algorithm works by embedding the cost and emission function as a function evaluation, where EMA will be run until the maximum iteration. And then we double check, we confirm again that the cost and the emission that we can get is minimum compared to others. So basically this is the flowchart of the EMA. Okay, we start by the number of population, get the function details and dimension, start from the initialization, as well as we calculate the initial function evaluations, and then we use the selection. And then there is two parameters in the EMA. You can refer to the original papers of EMA that we have published in neural computing applications. That is CR and K, if I'm not mistaken. So basically that two parameters that will distinguish between the exploitation and exploration process. So if the solution out of bound, it will be pegging at the boundaries or not, we evaluate and obtain the minimum cost as well as the minimum emission. This process will be run until the maximum utilization is achieved. So basically our aim to minimize the cost of generation as well as to minimize the emission of the generation when the power output is generated. So we move to the result and discussion. Basically we use the MATLAB 2019 on the MacBook Pro processor. Okay, and then this is the result for 10 system. Okay, the first one we compare with flower pollination algorithms, cuckoo search algorithm, as well as binary matrix optimizer. So as we can see here that the cost of the generation obtained by EMA is the minimum compared to others, but however there is a trade-off in terms of the emission. But however, when we transform the emission into the generation cost, the total cost still the minimum compared to others. Okay, however because the limited of the space as well the time, so for photogenetic system you can refer to our paper. So as a conclusion, the result obtained from the applying the EMA to the economic emission of dispatch for both 10 and 40 generators are promising. EMA consistently demonstrate the competitive performance in terms of power output, cost and emission optimization, and we have present the 10 generator system that EMA achieves the favorable power outputs and outperforming the compared algorithms. Okay, and then for the case of the 40 generators that you can obtain in our paper, basically EMA maintain a stable power outputs for the most generators and effectively meet the total power demand. Okay, and then EMA significantly reduce the emission compared to other algorithms. So overall, the result highlight the effectiveness of EMA. This is the first time that EMA has been implemented in the EELD, and we for the further research, the fine-tuning algorithm will be potentially enhance its performance and make it an even more robust solution for ELD problems. So I think that's all for my presentation. Thank you very much. If you have any questions, you can email to me at herwan@umpedu.my. With that, Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.